Today we're going to be looking at section 5.1, Exponential Expressions. And after today's lesson, you will be able to multiply and divide monomials, simplify expressions with negative and zero exponents, and convert decimal or standard notation to scientific notation and vice versa. So as we move forward in today's lesson, some vocabulary that you're going to be asked to be aware of. The first is a monomial, which is a number, a variable, or a product of a number and variables. Essentially, a monomial is a term of an expression. So 3x plus 2y plus 4x squared y. Each of these terms could be classified as a monomial. The second term you're going to be asked to be aware of is what we call a degree of a monomial. And this gets into when we start to classify functions as linear, quadratic, cubic, things like that. That's when the monomial or the degree of a monomial comes into play. And the degree of a monomial is the sum of the exponents of variables. And so as we take a look at the examples that we have, the first example, monomial x, that's x to the first power. And so if we look at the exponent or the sum of the exponents, we would say this is degree 1. The second term, 3x squared, again, when we look for the degree of a monomial, it's the sum of the exponents of the variables. And so we're solely focusing on the x squared. And so since that's our only exponent, that would have a degree of 2. 4x squared y, if we look at the x squared and the y, we have y to the first power. And so we would have x squared y to the first, and so the sum of those exponents is 3. So 4x squared y is a degree 3. 6x cubed y to the fourth z squared, the sum of 3, 4, and 2, that would be degree 9. X to the nth, if you have exponents that are variables, well, degree is the exponent, and so this would be an nth degree term. And if we look at our constant, the value of 6, there is no variable, and so we would say that the degree of that term is 0. Finally, in terms of terms or expressions that are not monomials, when we start to have roots or radicals with 5 square root of x, this is not a monomial because it cannot be written as the product of variables. So again, it cannot be written as the product of variables. Typically, when we're talking about monomials, we want integer coefficients or whole number coefficients, and the square root of x is not a whole number exponent. Finally, the expression x over y, this is a quotient of variables. And so again, when we start to classify terms that are monomials, if we go back to the definition, it's a product, not a quotient. And so when we're dividing with variables, that would not be a monomial. If you have any questions, please let me know.